All right, then. Thank you, everyone, for joining in today. Greetings, everyone. I'm excited to have Bionova with us today, presenting on the topic of embodied carbon and tackling life cycle emissions in the MENA region. Uh, my name is Jason, and I work for the Emirates Green Building Council. And first of all, I would just like to give a small introduction to the Emirates Green Building Council in case this is the first time that you are joining one of our events or our webinars. So the Emirates Green Building Council is a non-profit membership organization that was formed in 2006 with the goal of advancing green building principles. Our vision is for the UAE to be the global leader for sustainability, and we achieve this by basically acting as a hub for collaboration and knowledge sharing. We run several programs as part of the Emirates Green Building Council, one of which is the Net Zero Center of Excellence. The Center of Excellence was formed in 2018 as a think tank and accelerator to accelerate the net zero movement here in the UAE. We have three main objectives as part of the Center of Excellence, which is to act as a platform for knowledge exchange, drive policy towards decarbonization, and offer tools and resources to advance the net zero movement here in the UAE. As part of the Net Zero Center of Excellence, we are running this Net Zero webinar series, which you are joining us here today. I am also proud and excited to announce our partnership with Bionova Ltd, who are the developers of the One Click LCA. And I'll be giving a small introduction to our facilitators today. So we have joining us on call today is Panu Pasanen, who is the CEO of Bionova. We have Graham Devlin, who is going to be also taking over for the facilitation. And lastly, we have Aditi Chitnis, who is going to be supporting them. So thank you everyone for joining us today. I'm going to hand over the presentation now to our facilitators. And if you have any questions, please feel free to share them in the Q&A dialogue section. We'll answer them as we go through the presentation, or we'll reply back to you in chat. If you are unmuted, please do unmute yourself, and that's it. Thank you, everyone. So Panu, I'm just going to be handing over controls to you.
Thank you, Jason. And my screen should now be visible. So I will be talking today about embodied carbon and tackling life cycle emissions in the MENA region. The presentation is partly based on the presentation on a very comparable topic I did in Jordan recently in connection with the World Green Building Council event. And as it was mentioned, I will be starting this presentation with discussing embodied carbon from the point of view of the MENA region, especially if some of you are new to the topic. And I will take any questions and answers relating to this topic. And then after we have outlined the problem, my colleague Graham Devlin takes over and will present a solution for this, which is the outcome of our cooperation with EmiratesGBC called One Click LCA Planetary, which is now freely available in the Emirates. So with this program, we continue forward, and questions can be sent using the Q&A functionality at any time. So I will then answer them as we go. I'm going to talk about this using the following structure. So I will give a brief introduction about ourselves, about embodied carbon. I will discuss what does embodied carbon mean for different building typologies, what does it mean from a time perspective. I'm going to be also discussing what's the global status on this, and where is the MENA region in regard to the global status. Then I'm going to discuss benchmarking. How can embodied carbon be benchmarked? And lastly, how can it be reduced in the MENA region? And with this, I continue forward. We are Bionova. We are the developers of One Click LCA, which is an easy-to-use lifecycle carbon LCA and costing software. One Click LCA is used in more than 60 countries. We have over 60,000 datasets in the complete database of One Click LCA. We support LEED, BREEAM, and all the other commercial certifications that in any form use LCA in them, including SQL. We integrate with IES, Design Builder, Revit, and several other software packages. We work with global engineering companies, global construction companies, and regional specialists. Below, we just show a few of them in no particular order. In addition of supporting the construction businesses, we support also manufacturers and we support investors. Those topics, however, will not be covered today. One particularity of how we work as a software platform, as a business, is we provide different tools for different stages of the project. In the first stage, you have to choose your site. The site, of course, can have fundamental impacts on the carbon intensity of your project. Second, developing a design concept has a further fundamental impact on the carbon impacts of your project. And only then we move to the classical design stage. But the thing is that the big decisions may get taken in the earlier phases, so we provide specific tools for those. Those tools are called Site Designer and Carbon Designer. And from the design stage onwards is a classical LCA software where you can use design software to get the quantities and then EPD and carbon databases to get the emission factors for your project and then multiply them basically automatically and get your carbon impacts for the project. And finally, you can use it to benchmark. Obviously, certification is a big part of business for many regions. You are undoubtedly aware that LEED, for example, provides credits for both embodied carbon reductions as well as for LCA, as well as for EPDs for that matter. We do support those, and we do support pretty much any certification that has any form of embodied carbon or LCA in it. We do integrate with different design software. If you are an energy modeler, we do support the most common commercial energy modeling software packages. If you are a designer, we do integrate with Revit, and if you are a BIM manager, we do provide BIM management software integrations. And for everyone else, we do provide Excel and IFC as exchange formats. Embodied carbon impact of construction comes from several different stages. The digger in the mountains, as the first stage, in the first stage of life cycle, is extracting raw materials here, which are then being transported to a factory where they are manufactured. The extraction, transport, and manufacturing of the raw materials all causes life cycle impacts or carbon impacts. The transport of the materials to the construction site, the installation itself, and the transport and disposal of construction waste cause further emissions. All of this is called embodied carbon, and up to the point when the building is built, it's called upfront embodied carbon. However, when the building is completed, the materials need to be repaired, maintained, and replaced. And further, at the end of life, they need to be safely disposed of. And the emissions during the whole life cycle of the building are also called embodied carbon. The difference being is that what you have in the building as life cycle, embodied carbon emissions from materials until the point when it's built is called upfront embodied carbon, and everything thereafter could be called operational embodied carbon, but commonly it's just called embodied carbon. So We can have different life cycle scopes used, and when we talk about embodied carbon, it's good to ensure that you're clear on what scope of life cycle you're covering. Construction uses vast amount of raw materials. Global construction emissions until 2060 may be equal to 7 years of fuel combustion carbon emissions. Whether they will actually be equal to that depends on whether we do anything about it or not. This is largely determined by industry response because there's no intergovernmental action in a sufficient scale that would slow this down. Embodied carbon is basically just the next level of energy efficiency and energy grid decarbonization. We have been working with energy efficiency, well, you must know, oil crisis, right? Since then, we have started decarbonizing energy supply. Since about 3 decades, we have started working as an industry with embodied carbon about a decade ago. And now we start to go to point of view where actually carbon management is a thing. And you look at carbon holistically and not as separate baskets of operational and embodied carbon, and try to optimize the whole. Even if you didn't care about carbon, there's money to save. Why does this become possible is because embodied carbon is a design approach that looks at materials and materials use in a way that helps you to consider the materials used in the earlier phase of the project. When you consider materials used in the earlier phase of the project, you will also identify material saving opportunities. It may save you money upfront, so you can save capital costs, or it may save you money during the lifetime of the building in case, for example, you avoid replacements or you increase adaptability. Whether you are personally pocketing those gains, of course, depends what your role in a project, but this will give you a way to convince other parties in the project to play the ball and to work with you to achieve those reductions. You also have some external drivers, including regulations, certifications, and others to support this. As I mentioned earlier, the early phase is quite critical, and one reason why embodied carbon has not been successfully reduced in the past is because embodied carbon for effective action should be reduced in the earlier phase of a project. With One Click LCA Planetary, which we are outlining in later stage, we are reducing some of the barriers from addressing this in an earlier phase of a project. When you do the early design, you don't, of course, have high level of detail. The detail you have in the phase when you actually work on the project design. And this is the point where you typically do your lead LCA or pre-em LCA. When you work in the certification phase, you start to work with material suppliers, and engaging all of these 3 groups, investors, designers, and material suppliers, will help to achieve embodied carbon reductions with the respective decisions and the respective actions each of them makes. Then if we go into the embodied carbon project typologies and impact of time, first, we should understand that different buildings will stack up differently from embodied carbon point of view. Different building typologies impact embodied carbon in the following ways. Building use determines, for example, the lifespan of materials in the interior parts of the building. If you have a retail project, the interiors are renovated very often. Same can be true with commercial office space. However, when you have typical residential project, it will not get at least internal walls replaced in a high frequency. Or when you have a government building, the same is true. Secondly, the height of the building shapes embodied carbon. The proportions of walls and floors and load-bearing capability of the building will fundamentally change. You are in a region with exceptionally tall buildings. These buildings will, super tall buildings, use very significant quantities of materials, mainly because of the structural loads and wind shear and other factors. Different building types use, in some contexts at least, different material combinations. So sometimes because they require them, sometimes because it just is the best fit. And building types have different specific requirements. For example, hospital buildings in many countries have different seismic requirements than other building types, increasing the use of cement and steel. Other building types may have, parking requirements, acoustic requirements, and others. And finally, although this may be to some extent lesser problem in the MENA region, the foundations in some sites can be very heavy, which of course increases the impacts that you will have from the building on that site. And these typologies all drive the embodied carbon of a building and will make it actually required that you consider from the point of view of the specific project and what are you going to do here to be contextualized and work from that onwards. I have here some sample buildings with similar size broadly and per square meter impacts with just concrete buildings. These are from European context. So we have residential low-rise, residential high-rise, retail, office, hotel, and education. Here we have assumed uniform renovation cycles, which is doing not full justice to retail projects, which would actually use far faster renovation cycles. But you can see that just the per square meter impacts vary by almost 1/3 between different project types. This is just to illustrate that the type of building you will build matters greatly. And then if you look at the building impacts and where do they come from, very often they come from floor slabs. The floor slabs are very massive. In every building, there's a very significant amount of floors and the materials in floors. You also have high impacts coming from the envelope, not just because it's massive, but because it's high carbon materials. Envelopes in the Emirates, we can probably say that fair share of it is steel, glass, and aluminum, right? All carbon intensive materials. And finally, they also come from the impacts of internal materials and building mechanical systems. Why this is the case is because those materials are short-lived. So they do not actually last the whole duration of a building. So if you design a building for 50 or 60 years, most of these materials get replaced not once, but several times, thus increasing their material demand during the lifetime of a building. If we look at the building from the point of view of year one, excluding major foundations and building systems, we can see that for a steel and concrete-based building, those two materials account for 2/3 of as-built impacts, which is not surprising. These are the dominant carbon-intensive materials in all construction. However, if we start to look at it from a life cycle point of view, at year 50, we already have so many replacements taking place that the internal walls and finishings get replaced for that life cycle, that already 47% of the life cycle impacts come from those. But steel and concrete do not require any material replacement at that lifespan. If we go to 100 years, that share grows further. And we should note that building systems are not included here, so that will grow the share of materials that are being replaced even further. There's a question about replacement of concrete by other more sustainable solutions in Middle East. So I don't have a study, but we have several projects which have done really well. So it's possible to reduce these impacts definitely, but you need to define that ahead of time because availability of alternative binders is constrained in the sense that you don't get them on the day you ask. You need to ask for them ahead of time because they are not always stocked. Then if you look at the embodied carbon cycles in the built environment, to do this in a visual way, if we start from the basis, the infrastructure that we build around the buildings lasts for centuries, right? Then if we put the building structure up, it will last 50, 100 years, possibly longer, depending if there's a need for that building. And then we have the spaces and systems, which can last anything between 5 and 30 years. And if the structures are replaced once, that will double their impact during that life cycle, right? So if you are a structural engineer or you're writing a brief for a structural engineer, and the building is in any way significant and likely to be able to serve in a 100-year time span, then there's a very good case for actually requiring the materials and the structures to last that long, because otherwise you might run into the risk of basically requiring to rebuild a completely solid building otherwise. Regarding spaces and systems, you cannot avoid tenants changing leases. So if you have a retailer who's your main tenant, they can of course change the leasehold, and if that happens, then you have to accommodate to the requirements of the new tenant. But what you can do is you can design for disassembly. So if you do design internal walls that are movable, there's a company in Turkey making them, for example. I can't remember their name right now though. You don't have to demolish them, and you don't have to buy new ones. You can just move them. And this obviously reduces the capital cost of the renovation, increases the time, makes it faster. Sorry, doesn't increase, but makes it faster, and reduces the carbon impacts of those renovations. Systems replacements you cannot completely avoid. There's some mechanical systems, they just run into end of life cycle, but you could still reduce them. To give a practical example, you could use textile ducting, for example, instead of classical metal ducts for ventilation. This can save quite significant amount of embodied carbon, and it does provide more flexibility as well. And finally, when we get to the surfaces, well, when you have to redecorate, you have to redecorate. I suppose that's kind of considered a given, and that there's no scenario in which you can reuse paint, but there are finishing materials that you can reuse, and there are finishing materials you can recycle, and there are finishing materials that you can adapt. So if you can design or commission an interior designer for a project, you can most definitely look at reuse opportunities. For example, in our own offices, which we renovated last year, we were able to reuse 100% of the floors, and we were able to achieve approximately 80% material savings versus the typical tenant improvement project. This was of course not trivial. We had to design some solutions for this, but economically it worked out really well, and carbon-wise obviously fantastically, and the offices worked out really nicely as well. So in each of these let's say design levels, from infrastructure to structural engineering to spaces and systems to finishing, you can work with specific solutions adapted to that time span and to those needs, using embodied carbon and life cycle of the solutions that you're working with as guiding factors for your design decisions. And then if we look again from this point of view, when we include also spaces and systems and surfaces, so everything into the project, our total year one carbon emissions, which would have been 520 kilos here, could become almost, well, more than triple basically over a decade, or not over a century, of course. And this, I think, is something which you should take away with you and look at the carbon cycles of materials and what are the options and opportunities for adaptation that you have there. Then a few words about where's the world on this and where's the MENA region on this. And I start sharing, just for information, Embodied Carbon Review, which is a report we wrote in 2018, so about 2 years ago, which was a review of all the global green building regulations and rating systems and the role of embodied carbon in them. It's free download. You can find it on the link mentioned there if you want. One of the key findings of this report is that globally there were at 2018 105 regulations and rating systems that directly address embodied carbon. In this, we have only considered green building systems or regulations which are either carbon only or multi-criteria systems. We have not considered only energy systems or only waste systems, mainly because there's infinite number of those, and if they don't by definition include embodied carbon, there's no point to look into them. And if you look at the regional pie chart here, the green part of the pie chart says basically how many systems address embodied carbon, and the gray part says how many do not. And if you look at this from 2018 point of view, MENA region was having very high level of scarcity of embodied carbon being addressed. Basically because of, I would think, not having a strong history in building regulations, which has definitely spurred ahead other regions such as continental Europe and Northern Europe. However, considering MENA region is a very international region, and many of the building regulations and rating systems that you use are international. This is a standard feature of all the international systems. If you do LEED, if you do BREEAM, if you do Living Building Challenge, or any of the other international systems, those all incorporate embodied carbon. In these systems, 5 main carbon reduction methods are used. The starting point is reporting carbon, so it doesn't actually ask you to achieve any level of reductions, just give you declaration that this is how much we have, and that's all right. The second level, which is used, for example, in LEED, is to do a carbon comparison. So you compare baseline to the proposed design. Third level is carbon rating. So the projects are actually rated based on carbon, and LEED 4.1 already starts to do that in the sense that the more carbon you reduce, the more points you will get from it. So you don't get fixed points anymore. And at the more demanding end, we have carbon caps, relatively rare systems, and decarbonization targeting systems, which actually have a carbon cap typically and then require offsetting all the residual emissions. And basically, when you're required to offset the residual emissions, that means you have to pay money for it. So it's basically a carbon price, meaning that you will save money for every ton of carbon you do not emit in any of the covered phases of the life cycle. Whenever we start on a new market that doesn't have a lot of experience with this, typically it's a good idea to start in the earlier phases just to learn and to get experience And carbon reporting is something that's worth using as a, let's say, test bed or learning environment for learning how to design better buildings before moving onwards to the more demanding levels. There's a question which I will take in the end, in the question and answer section, just noting it. And some of these systems are highly efficient. Carbon rating starts to work pretty good. Carbon caps work even more, and decarbonization, of course, works the best. Decarbonization works the best because every ton of carbon you emit has a counterfactual cost. Now, not everybody wants to start a project which is subject to decarbonization price. So you may also make a sacrifice in terms of level of efficiency you have in terms of carbon reduction and the level of prevalence. And this chart takes probably some time to explain, so we'll try to explain it to you with time. And it shows the prevalence of the not applied, most basic, intermediate, advanced, and most advanced carbon reduction methods by geography. And at the bottom of each of the columns, which are regional, this red bar means no systems applied. Deep orange is most basic system applied. Orange is basic method applied. And then different shades of green, from lighter green to the darker green, means intermediate, advanced, and most advanced carbon reduction methods used. And in here, what we can see is that basically continental Europe and Northern Europe are leading in terms of adoption of carbon reduction systems by comprehensiveness. International and European systems, however, have higher prevalence, mainly because nobody can do an international rating system without including embodied carbon in it. And then in MENA, as we have seen before, there's not really that much done today. In North and South America, in the domestic market systems, so not including LEED, which is international system, they are also not that widely adopted. Asia and Australasia, more or less the same. Global infrastructure systems, however, do consider this more broadly. We have discussed embodied carbon, typologies of buildings, impact of time. We have discussed where the different markets are, and then we could go to benchmarking. We have discussed that different building types have different impacts, that different regions can also have different impacts. And Carbon Heroes is what we used as a starting point for carbon benchmarking. The program is already completed, and we achieved about 2,200 buildings in the first phase of the program. And we continue this with the planetary program, which Graham is explaining to you later on today. And we have used these to create national, regional, and international benchmarks for building types. Why we do this is obviously to capture different variations between buildings, geographies, and so forth. The Carbon Heroes benchmarks has another purpose. It is allowing you basically understand embodied carbon in a relatively simple way. If you have ever seen or worked with energy performance certificates, you will recognize how this looks like. And we are giving a rating from A to G based on the data sets for each region, and giving per square meter embodied carbon of a project for the whole life cycle of a project. Then continuing to reducing embodied carbon in MENA region. The starting point always is the total project material use. You should always focus on the biggest items. For example, how much materials you actually need. If you have a site which requires huge amount of, slaked lime or cement underground, that site is not going to be very good no matter what. If you have a region where you are required to build parking places, you can't do as much about it, but if it's based on commercial requirements, you should definitely limit material use for parking structures so you can build for people. And you can also design efficient shapes so you can reduce the amount of materials that you need per every square meter. I will take the rest of the questions in the end to be able to continue the presentation. So, few rules of thumb for materials choices. So once you have an idea that you're actually somehow materials efficient with your project, you should start to look at what materials you use and how you use them. As is already pretty clear, I think, at least to those asking questions, is that reducing cement and concrete is the key, and it should be on reducing the use of ordinary Portland cement. So of course you need some form of binder. What binders you then use will depend on what you can get on the region and what you can get for the project specifically. If you can use traditional materials, especially if they are low energy ones, they are preferable. I should, however, mention that rammed earth walls, which are stabilized with cement, are not any better than classical concrete walls. And you should also invest in design. So you should avoid oversizing and business as usual, especially for structural design, because you can really save a lot of materials if you do your structural design with materials efficiency in mind. We wrote a guide called Top 10 Design Commandments for Cutting Your Building's Embodied Carbon. Is available in the link in the presentation, and you can probably find it also if you just Google it. You can also consider some of these guidelines. The first thing to avoid when you want to do a carbon efficient building is to build a building for need that's not long term. If you can't ensure that the building has purpose over a time, you shouldn't build it. Adrian Smith and Gordon Gill, architects, were recently asked to build an iconic building at the center of the expo. And they were asked to build whatever, right, as the highlight of the expo. And everybody would expect, as specialists of super tall buildings, that these people would, make a skyscraper. And they came back and they said, no, we should build a park. And why they came back with this proposal to build a park is because basically they felt that there were enough skyscrapers and there were almost no or not enough public spaces, and which is not working out for people who actually live long term in a city, right? So they actually decided the centerpiece of the Expo project should be then a public park. And the public park actually can have a very long-term need because there's permanent residents and not just expats, which has been maybe the case you were building for expats 20 years ago or 30. But the demography has changed. And there's people with families and they need other things. So they actually avoided building a skyscraper because they felt there were plenty and there was no long-term need for further skyscrapers, but there was really a deficit in terms of livable spaces. I have talked about the challenging foundation conditions a few times. I think that's already now clear. And low carbon structural material can be the other. So if you are able to find a way to procure a low carbon cement for your concrete or use another material altogether, that will basically do the trick. If you are able to just specify low carbon products using local or even imported manufacturers, as of course case may be depending on the material category you target, you can achieve significant carbon improvements. Compact shapes can further help. Thin slabs definitely help. When we say thin slabs, we should also consider other structural design solutions. So this is just one of them. Avoiding needless parking structures has substantial saving potential. Flexible space elements allow you to reconfigure your building over its life cycle to adapt to different needs without repurchasing the materials for doing so. And you can also avoid low-value elements. There are materials that you put in buildings that you don't always have to put. Some of these include, for example, acoustic ceilings. Acoustic ceilings are not actually required in all the spaces of an office. They are required in the spaces where you do the type of work that requires it. There's categories of materials that you actually put in buildings as a standard, which do not serve a function. And if you can convince your investor that doing away with them is a good thing, you can save A, carbon, B, money, and C, because this will be visible, you can make a point that you did this on purpose. So it will be something visible, which is a benefit compared to some of the other things that you can do, which you can't show, which you can just explain. Choosing long-life products is of course an option. And if you do these combined measures, you can reduce embodied carbon of a building by nearly 50%. Of course, the exact figures will depend on your context, but there's really significant embodied carbon savings you can achieve with design practices. If you work with an investor, the investor should very simply set requirements and verify they are delivered upon. This has been proven to work so many times, most prominently by the Norwegian government, who has extremely stringent requirements on this. They require carbon reductions. They put them in the contracts. They verify them. They assign a third-party expert to verify them. Third, they start on carbon reductions early in the project. Why they do this is to avoid lock-in to high carbon trajectory. And fourth, they understand the feasibility themselves, so they can develop a view of what can be done today, which avoids them being actually basically locked in to a scenario where they are told X, Y, and Z by different people and not being able to form an opinion which of these statements holds water. There's some insights coming out for cities releasing today. We have been working quite some time on a paper called City Policy Framework for Dramatically Reducing Embodied Carbon. It's going to be available during today at embodiedcarbonpolicies.com. This has been written in cooperation with some of the world's leading cities, including San Francisco, New York, Vancouver, London, and others. It includes 52 policies which cities can adopt to reduce embodied carbon. In the Emirates context, I think also individual Emirates can be the right level to adopt these. So it could perfectly work in any urbanized Emirates context. And now I will start answering questions. There's a question on if there's any study in place to recover the materials from demolition projects to be integrated in new construction projects. Are those types of interventions able to be measured? Right, so you cannot recover materials from demolition projects, but you can recover materials from deconstruction projects. So if somebody knocks down the building, everything is destroyed. But you can very well recover materials from deconstruction projects where recovery of materials is a purpose. And for example, Portland, Oregon, San Francisco, and Vancouver have requirements pertaining to this category of problems. So they actually require that you work with the deconstruction contractor. They don't allow you to actually work with a demolition contractor. And they have a list of approved deconstruction contractors. And why is this? Because they can then ensure that the materials can be reused. And to answer like more specifically, it's absolutely possible to measure. And it's absolutely possible to achieve high rate of success. But you cannot do it with demolition contract. You have to do it with deconstruction contract. And that is lower. And it requires that you always start with a survey of materials that are available in a project. So very good success stories, mostly from Nordics and America so far, and Netherlands to some extent. Then there's a question, how are we benchmarking? Does this include all typologies and building? So is there a specific limit to this? So we do actually create the embodied carbon benchmarks from projects people calculate with the software. So any project that gets calculated feeds into the statistical benchmark database. And the kind of benchmarks we publish then basically depend on the quality of the data. So if there's enough data for a specific region and building type combination, then that gets made a benchmark. So that's the extent of these benchmarks. There's a question, what is the evidence for rammed earth reinforced with cement being no better than traditional concrete? Mainly because in rammed earth reinforced with cement versus aggregate reinforced with cement has the same climate impact if it uses the same amount of cement. So it fundamentally depends which is the better aggregate, the rammed earth or the aggregate. And as basically aggregates used for concrete tend to be optimized for reducing the use of cement, if such aggregates are available, that's basically the case. So rammed earth sometimes requires more than 10% of volume of cement, and that makes it already pretty high in terms of impacts. But of course, if you can achieve same performance with any solution using less cement, it would be better. Also, you can do rammed earth with fly ash or blast furnace slag. There's a question from Mark Lavery, whether there's a database for carbon data available to suit Middle East market. Most data publicly available is from UK, Europe, and US and does not reflect Middle East market. So in One Click LCA, we actually do integrate all carbon data globally. Oh, I don't think actually I don't have it here, but so we have over 60,000 data sets, and those data sets cover everything everywhere. We do have data for Middle East. We do also have all the manufacturer EPDs for Middle East, as well as generic data for Middle East. and we do integrate more. So every time our manufacturers make new datasets, we do integrate them. There's a question whether reducing emissions and operation carbon is expensive in terms of cost. Can we capture cost savings in tangible project to convince clients to include this in contracts? It is expensive if you do it late, like most things. So if you have a project which is like at specification phase and you say, okay, let's buy the lowest carbon products we can find, without having ensured that you actually save materials, then it's no money saving anymore. The money savings come basically from starting early, because then you can save quantity of materials. These savings typically, because labor is also part of it, and labor may not be saved because you don't replace structures altogether, you just reduce the amount of material in those structures. Typically is below 1%. There's a question on Expo Dubai, who has applied carbon reduction measures in many aspects, designs materials with EPDs and so forth. Yes, so so far as we know, all the EPDs made for Expo Dubai are in our database. If they are not, our customer support will integrate them. So most definitely they can be used. There's a question on if there's any software on LCA that's linked to LEED. Well, you know, I mean, I was kind of hoping that that would have been clear in this presentation. So One Click LCA comes to mind. Not the free version, but the commercial version. There's a comment, wouldn't it be unfair to combine different typologies into one benchmark? High price can't compare to a 4-story building. Yes, of course, that would be unfair, but that's why we don't do it that way. So we combine buildings typologies which seem to be appropriate. There's a question on what materials we have for EPDs in the database. I think I will let Graham answer that. So we have something like 40,000 EPDs probably, but then they depend on which region they are. So if you ask this in the MENA region sense, it will be different than globally. And possibly, there's a question on, do we have a benchmark project versus improved carbon footprint where One Click LCA was able to achieve demonstrate reduction? So this may be not well communicated in the sense that we are, you know, the world leader in this LCA for buildings. But if you want to go to oneclicklca.com, you can find resources and case studies there. So that could be one way to find cases. All right, I believe that should have covered the questions. So if there's no more questions, then we continue with the next part of the presentation. And I will hand over to my colleague Graham Devlin. Graham, you can start sharing your screen at any time.
I think you might just need to stop sharing for a moment, Panu. Okay, so my screen should be shared now, and I hope you can all see it clearly. I'll just pick up where Panu left off with a short introduction to One Click LCA. Then we'll move into One Click LCA Planetary, our free embodied carbon tool. Then we'll have a live demo and discuss some use cases and applications for the software. And then we'll discuss about the availability of this new tool and a little bit about the differences between Planetary and our paid versions. And finally, we'll finish up with some questions and answers. So some random and relevant information about us at Bionova Ltd and One Click LCA. Our headquarters is in Finland, but we have local staff in the UK, France, Brazil, and India too. Our staff is made up of 30 experts, comprising of 17 different nationalities. The company was founded almost 20 years ago, and we've been doing life cycle assessment software for the past decade or so. And that software, One Click LCA, is used in around 60 countries today. We are working for market transformation at all levels. We're here to decarbonize the construction sector, starting at the top by shaping the business environment that we're in. We aim to do that by enabling development of climate positive facilities as a standard for tenants, by conducting policy work and report publishing to facilitate carbon regulation, and by helping investors to add carbon priced investments to their portfolios. This allows us to help the market to create an environment where builders and designers can develop projects with large scale, regenerative or zero carbon objectives. And in turn, this provides new business opportunities, for example, for manufacturers for decarbonized and circular products. As Panu mentioned, we have got a global materials lifecycle assessment and carbon database. It is by far the biggest globally. We have EPDs from all over the world, and it's probably safe to say that over 95% of the world's EPDs are in our database, and we're constantly updating them. There may be a chance that some very newly published EPDs are not yet included, or that we have rejected an EPD for quality issues. Because when we integrate EPDs, we independently perform checks on that data to ensure it meets our requirements. And if it doesn't go in. We have a quality audit process in place to verify that data, and we use metadata to enhance it so that it can be used in a consistent and robust manner for additional calculations. As well as EPD data, we also provide generic data sets that are localized for the whole world. And there at the bottom, you can see a link to our FAQs where if you want to see all the databases that we integrate with, you can check them out there. So if we take a look at One Click LCA database expansion and practice, in Q1 of this year, around 400 data sets have been added every week. So in comparison, we're adding more in a week than some other tools on the market have in their entire database, albeit that their database is global than just for a single market. However, it does add up. So we're well into Q2 now. So we'll likely need a higher range for the right vertical axis here as we break through 7,000 data sets for the year to date soon. And the reason for bringing this up in this particular presentation is because we're using this same database to deliver One Click LCA Planetary. So with that, let's move on to discuss the tool itself, One Click LCA Planetary, our free embodied carbon tool. As mentioned, we've been promoting low carbon design for over a decade. And while advanced economies like in Scandinavia or France, the UK or the Netherlands, for example, who are engaged in sustainable design, we haven't yet been able to reach emerging markets and those in the global south yet. And with One Click LCA Planetary, we hope to change that. So One Click LCA Planetary is a free tool, and it helps everybody decarbonize their material design. It's focused on carbon intensive materials, and you can compare and optimize design options and choose the lowest carbon products. So specifically, what can it do? It calculates cradle to gate embodied carbon impacts, and material efficiency of the 10 most carbon intensive material categories. When we say cradle to gate, we're talking about life cycle stages A1 to A3. So the supply of raw materials, their transportation, and the manufacturing process. And the material categories included in Planetary include ready mix and precast concrete, cement, steel, aluminium, bricks, glass, insulation, wood, and gypsum. So it doesn't have everything. There's no building systems or finishes, paint, etc. It's just those top 10 most carbon intensive materials. And the scope, it's the simplest scope that you could have, which also means that it's the easiest to adopt at scale. And that's exactly what we want to achieve. So you can compare and optimize structural design options to reduce material quantities and find and require the most sustainable materials and products for procurement. One Click LCA Planetary is available in 9 languages and currently in 16 countries. One of those key features we just mentioned is to compare embodied carbon and material efficiency of designs. So design against design or design against as built. You can use a more classical design, say, as a baseline, shown in the illustration here in blue, and compare it with the more circular option in orange. You can compare the structural solutions and the different material solutions. Although this is just for illustrative purposes only, in the graph on the right here, we can see that the circular building reduced its carbon by 17% by increasing the use of wood and reducing concrete and steel, for example. Another key feature is to identify hotspots and choose low carbon product types, specifications, and manufacturers. So you can use it to find the optimal balance between materials like concrete, steel, and wood. And you can use it to choose optimal specification to meet the objectives for your project. It also helps you to pick the best products and manufacturers to deliver your project while limiting the carbon impacts. And as you can see here, the results are given in carbon impacts and mass of materials. And we did it like this because understanding materials efficiency is key to unlocking carbon reductions. You can't just specify low carbon products without also first only using the amount of materials that you need to use. And this is how the results report looks in One Click LCA Planetary. So you have the material categories down the left-hand side there, and across the top you can see the global warming impacts as tons, the global warming impacts as kilos of carbon per meter squared, the mass of raw materials as tons, and the mass of raw materials as kilos per meter squared. And if you don't use a particular materials category in your project, for example here precast concrete, you can hide those empty rows on the right hand side. And the grand total then for your design is given down at the bottom. The EPDs in Planetary are the same data sets as those in One Click LCA commercial versions, with some important limitations. So the first being that it has to be in one of those covered categories we mentioned. And the second, it has to be from the market where the product is available. So Planetary provides local/regional and generic databases, whereas the paid version of One Click LCA includes global data sets and also those that are licensed for a fee. In Planetary, you can also make requests for EPDs to manufacturers. And this is how the feature looks. So utilizing this feature, it does require you to have an organization account set up, which we'll try to do during the demo if you've got time. It's free and it only takes a few clicks. We do this so that the manufacturer can see that these requests are coming from genuinely interested parties and then decide whether to create an EPD. In the form, you can fill out the country, product type, manufacturer name, and a short description of your request. And if there are any matching EPDs already in the system, they'll be shown so as not to send requests for already available data. And if there isn't, you can continue to provide an estimate of the quantity of material needed for your project, some other technical requirements for the EPD, and you do also need the email address of the manufacturer to send the request. Once you have sent it, the manufacturer will then receive an email similar to this, outlining what's being asked and by who, and they can click the button here to view the request details. There's also a link to some information on why they're being asked for an EPD, and that way we don't have to explain each time, and the manufacturer can access high quality background information on why these matter. And here are the details that the manufacturer will see, basically from the form that you filled out. And if they so choose, they can use our pre-verified EPD generator to create an EPD if they wish. Of course, they're not obliged to do so. However, the option is there for them if they need a cost and time efficient way to create EPDs. So now that we've covered the introduction to One Click LCA Planetary, we can do a live demo of how the software actually works. Because I already have an account created, we can just take a very quick look at what the registration form looks like. So if you haven't already created an account, please visit oneclicklca.com and click free trial in the top right corner. You'll then be presented with this short registration form to add your name, email address, country, etc. At the bottom, there's an option to sign up for our newsletter, which I would recommend doing, and a link to our service terms, and then you simply click register. You will be sent an activation link by email, which you need to click within 24 hours. And you'll then be asked to confirm some settings like language, unit system, and regional settings. After you click next, the pop-up will ask you to confirm your email address or modify it if necessary. And then you'll be able to choose use One Click LCA Planetary. So now I'll jump across into the software itself so we can continue the demonstration. So here is where you can see the main page for oneclicklca.com, and the top right corner here we have free trial. So you can click there, or if you already have an account, simply click login. So on this main page, once you're logged in, on the left hand side here you can see some updates. When was the last update to the software, database log update for example, and other general updates here. So you can close that for now. And on this main page there are some publicly available projects. Someone earlier on had asked about a project where you could compare something. So for general Middle East, there's this project here that you click into and have a look to see the different designs and how they were able to achieve some savings. So I'll just jump back to the main page. So when you're starting your first project, you'll have this option available at the top, Planetary Project License Available. So let's click that, and it's asking us to provide some mandatory information. So we've got to give the project a name. So let's call it My First Planetary Design, and what type of project it is. So all different kinds of projects listed here, and we'll just click the first one for apartment buildings. Country here of United Arab Emirates, because that's what I had in my sign up. And this note here is letting us know that Planetary is available in our country. You can add the address, close floor area, which I'll just add here, number of above ground floors, 4 is here. It's a pretty small building for UAE, but let's go ahead with that anyway. Frame type, so here you can choose if you already know what the frame type will be, or you can leave it not sure if you don't yet know. We'll just choose concrete frame for now. If you are pursuing any certifications, while it's not used here in Planetary, so you can leave this blank. If you wish, you can, of course, put in lead, for example, and you'll be shown the options, and you can add that here. Additional information optional if you wish to use it, but we can click save and go forward. So here you can see that in partnership with EmiratesGBC, we are ready to use One Click LCA Planetary. Okay, so we've got no information in here yet. We're going to start exactly from scratch. So let's get started. So our new design, I'll call it my first planetary design. So it's a concept or schematic design, and we've already enabled the tool here. It's One Click LCA Planetary Middle East and Africa. So it's for the MENA region. It's not country specific for this region. And here we've got new construction whole build and concrete frames, what I chose earlier. So let's click OK and move forward. So we have my first planetary design here, and in red it's telling us that we can input some data here. If I open it, we can view results, but there's no information there yet. Building materials, building area. There's no option to import data in this free tool, and that is just in the paid versions. Well, let's go to building area to start. So this warning is telling us here that we're missing some data, and that if we click here, we can add it. It wants us to add the gross internal floor area. So we click here, and it's pre-populated with what I wrote in the new project form. So if we're happy with that, we can either click save up here in the top, or simply moving to a new tab will also save any new information from the one you just entered. So now in building materials, you can search for materials in a couple of different ways. So across the top here, we've got a lot of different filters that you can use. So for example, you can choose concrete, and it will limit any of your search results to that material category. Let's just add some generic materials in here so we can take a look at what the results are. So we can start off, we'll add some ready-mix concrete. So now it's giving us a list of ready-mix concrete that we can use. So here we can see there's some local generic data, also some local manufacturer specific data. So let's use some of that specific data here, and let's just choose the first one. I don't have any project or specific quantities in mind, so let's just put in some figures so we can add some materials. So now we've got our concrete, let's add some reinforcing steel. So we've got 10 matches here for rebar, and let's just use this 90%, let's say, recycled content. And we'll add 10,000 kilos. And also just to pad out our results so we can see a little bit more, let's also add some external walls. So we can again add some ready-mix concrete here for external walls. So there's one here that shows 10% recycled binders as a typical one, so we can use that. And again, we'll just use some figures here. Let's also add a different material, so let's put some gypsum. We have local manufacturer specific data. And let's choose the first option here. And let's add one more material. Let's add glass just to add something different. So glass panes. So we've got float glass single pane here. And also just at the end of the description, you can see a question mark, which you can click for more information. I will show you some more details of the technical specification and where the data sources come from, etc. in this additional information window. So let's choose this and we'll just add, let's say 50 square meters. So we can click save. So our quantities are in there and we can go to results to see how it looks. So as we saw in the presentation, this is what the results table looks like. So you can see the different material categories along the left-hand side here and the results given in tons, kilos of carbon per square meter, and then the mass of raw materials in the same. As I mentioned before, you can click hide empty and any empty rows will disappear, so you can have a nicer sort of presentation table, let's say. In this most contributing material section, you can check to see which ones are contributing to the most carbon emissions. So here we can see also these colored sort of carbon clouds, let's call them, you know, range from red to green, with red being sort of the worst and green being the best. So there's a couple of materials in here that we perhaps aren't the most efficient. And down at the bottom, then we have our results graph, which will show us exactly those emissions are coming from. So which materials, which element of the building, for example. And there's different kinds of graphs to see. So you've got pie charts, bar charts, columns, and also tree maps. So here we can clearly see for the limited materials we've entered that the ready mix concrete is the one that's contributing the most carbon emissions. So one thing that we talked about quite a lot was about being able to compare designs and compare materials. So what we can do is we can add a brand new design if we wish, or we can copy design that we've just made and edit some of the materials to try to see where we can make some improvements. So if we click on my first planetary design here, we can click copy. And let's just change that to my second planetary design. And we'll leave all the other values the same and click add. So no surprises, they are exactly the same. But if we go into the second one, we can make some changes to the building materials and see what kind of results we come up with. So for, let's say, the ready mix concrete, we can add, let's try to add one with some different specifications. So we used this one previously, and let's just add with 60% here instead. So we can just add the quantities here, and we can either zero out the previous one that we had, or we can completely delete this entry. Let's also change the reinforcement. So we had 90% recycled content previously. So now we can, let's say, add the typical one of 97% recycled content. Let's zero out this one. And let's say we want to do the same for gypsum. So previously we've used this one, and now we'll go and use the second one of the local manufacturer specified data. And likewise, we'll do the same here and zero out gypsum. Okay, so if we click save again, It shows here already in this green bar that we have reduced carbon emissions by over 10%. If you go to the results tab, then we'll be able to see how we've been able to achieve that. So the most contributing materials again. So these materials with 0 here were the ones we'd previously been used, and this is the new set of materials that we have. These are shown because we didn't delete them, we just put 0 in the quantity. And again, the graphs are the same. So what's most interesting then is to compare those two designs. So we compare design with our first planetary design. In the results table, we can see exactly what metrics we were able to improve on in each of the material categories. And as we can see here with the gypsum, where we used a heavier plasterboard, that the results actually went the other way. If we go back to the main page, here we can look at we'll just go straight to all graphs to be able to compare the two. So in terms of global warming potential, we're able to reduce down to just below 90%, so over 10% reduction with just some small changes like that. We haven't used very many materials here, so there's not too much to read into this particular graph. But in terms of the elements, the biggest reduction we've made there is on the foundations. And comparing the elements here, external walls hasn't changed so much. So that's what the sort of comparing can be done in terms of the designs that you have. I mentioned about EPDs previously and how I think we're doing pretty well for time. So let's try to also then create an organizational account so that you can also request EPDs. So if I go out to my main page and then click on my design and my name here, I can create or join a company account. So if I click here, Bionova Planetary, United Arab Emirates, and put the address here. So let's just say Main Street and the town, let's put Dubai, country, United Arab Emirates. And here you can change the social carbon cost if you like. So let's say you want to change that to local currency. So this is currently set at €50. We can change that to 200 AED and click save. So very quick and easy to do to set up the organization account. And now in the software, you can request for EPDs from manufacturers. So in this section, once we're in the project design, request for a new EPD from a manufacturer. So if there is a particular material that isn't in the database and you need it for your project, you can come here to request that EPD from the manufacturer. Also, one thing that we have here inside in the tool is a dedicated knowledge base and help center, so you can receive support if and when you need it. So this help button here, and the drop down you have customer support center. You click onto this, a new tab will open, and here we have a section for One Click LCA Planetary, and there's some basic articles about getting started. These video guides have a 5-step tutorial essentially on how to create your first project, inputting data, navigating the results, comparing your designs, and also request EPDs. So very similar to what we've just run through there. There is also a community forum. If you can't find an answer to your question, you can ask it here. So that pretty much covers the demonstration. I hope I didn't move too fast for anybody who hasn't actually created an account just yet. For now, I will jump back into the presentation. Okay, so there we just looked at how to use One Click LCA Planetary. And now we'll discuss a little bit about some of the use cases for it. So there is quite a range of use cases, and our main goal is for all stakeholders in the construction industry to want to invest in, design and build materials and carbon efficient structures and solutions. One motivation for doing that could be that you have transparency requirements from an investor, a bank, or potential buyer, something that is becoming more and more prevalent. You may also be an architect or a designer who simply just wants to do low carbon design, whether you're being paid for it or not, and Planetary can help you do that. Besides design, you can use it for specification. So you can use the available EBD library to choose the lowest carbon products for your projects. And also, if you're at the top of the construction supply chain, like let's say you're a construction management company, you can use it to require your supply chain to provide you data and develop their capability to respond to you with low carbon solutions, because working together with your supply chain will increase your opportunity to significantly decrease your carbon impacts. They're just some of the use cases, and they're certainly not exhaustive, and just some ideas for its application. Panu mentioned this city policy framework for dramatically reducing embodied carbon already, and this new document that's coming today will give you some more ideas perhaps on how you might use One Click LCA Planetary. It is developed by CNCA, the Carbon Neutral Cities Alliance, and ourselves at Bionova Ltd in cooperation with Architecture 2030. So it's written, ready for publication, and will be ready for free, available at www.embodiedcarbonpolicies.com. So please check back later today to download it. We'll now discuss a little bit about availability and extend it to new countries. The majority of you attending today may already be in the United Arab Emirates and have access to the tool, but for those of you who are not, these are our current partners and 16 countries that the software is currently available in are the USA, Rwanda, Poland, Hungary, Ireland, Chile, Jordan, Finland, Italy, Russia, Romania, Slovenia, Spain, Singapore, and of course the UAE. And we are looking to launch in any country with a partner organization that one is committed to promoting low carbon design and construction, is ready, willing and able to deliver training and promotion in this subject. 3, that has a form of national coverage and the ability to reach a significant portion of the market. And 4, who sees the potential to change the market faster with this cooperation. So if you have a use for it or know somebody that has, and it's not available in your country, and you know a potential partner organization, please do spread the word. You can get more information at oneclicklca.com/planetary, and all partnership queries relating to Planetary can be sent to planetary@bionova.fi. We'll now discuss a little bit about the differences between Planetary and the paid version, as some of you may already have commercial licenses or are interested to learn more about what our tools can do. So there's just a small table here summarizing differences of the two. So with One Click LCA Planetary, as we discussed, the impact categories is simply global warming potential. And we're also looking at the mass of materials. And it's for the life cycle phases of just A1 to A3. It doesn't comply with any of the certifications like LEED and BREEAM, and it doesn't integrate with BIM, The database includes the 10 most carbon-intensive material categories for each region, and it doesn't include databases that are licensed for a fee. The functionality, as you've seen, is basic, but it's very intuitive, so it's easy to be able to design and compare your building elements and materials. It just produces a standard report and has online resources like we looked at in the knowledge base and the community forum. The commercial versions, on the other hand, they have any impact category that you wish to look at, and all life cycle stages. They're compliant with all modules for certification and all standards too. You can see a list of all the integrations on our website, and all kinds of materials, anything that's required for your building project is included in the database. The functionality has some added features like generating Excel reports, identifying hotspots easily. You can split and change materials. There's some more advanced visualizations and other results in the sidebar, which you can see from our pricing page. The reporting does come in different formats, and commercial versions do offer professional support and training. And we've discussed a little bit about EPDs, or environmental product declarations, and our commercial version also has modules for creating those EPDs for your construction projects. So it's completely separate to the building or infrastructure tools. It is fully compliant with the standards, and it uses Echo and Vent as the background database. You can import building materials from Excel, and you can use it with any program operator you wish. We have different kinds of tools for EPD generation. We have Carbon tool. We also have a flexible tool where you have sort of more freedom to choose exactly how your EPD is created. And we also mentioned the pre-verified EPD generator, which is a faster and more cost-efficient solution for specific industries. I think now we can move to the question and answer section. If we have any questions, I think my colleagues Panu and Aditi have already been answering some of those questions. But if there are any others, I'll be happy to take them now, or perhaps Jason, you want to say a few words.
Yeah, no, let's give it maybe a minute or two if anyone has any questions to ask the experts over here. So now's the perfect opportunity to do so. All right, so if there aren't any questions, I believe you can get in touch with us at EmiratesGBC. You can email us. You can visit our website as well. If you have anything, any specific questions regarding our partnership, you can also email Bionova. As you can see, the emails are there on the screen as well. If you have any related questions, please feel free to email them directly. The presentation recording will be shared soon, so just hold on for maybe a day or two, and we'll send out the recording to all the participants here today. So thank you everyone for joining in. There's a question that just, all right. So that's it from our side. Thank you so much, Panu, Graham, Aditi, for your expertise and your knowledge and for your time today. As everyone mentioned today in the webinar, so One Click LCA Planetary is free for all UAE companies through our partnership with Bionova Ltd. So make sure to utilize it, have it, explore around, and also give in some feedback, as they are welcome to feedback, especially from the MENA region as well. So we can also contribute in our way to the path to decarbonization. So thank you everyone for joining. Have a good day.
Thank you. The webinar ends.